Hello everyone, welcome to Brilliant Group of Institutions Qatar. We're going to continue with the part 2 of Relations and Functions MCQ discussion for your CBSE Grade 12 Mathematics examination. Okay, so right away let's go to the questions. So now, the first question we're going to discuss here is f is a function from 2 infinity to r and f of x is defined by x squared minus 4x plus 5. What is the range of f? This question can be very directly done. It is said that f is a function from 2, infinity to r. F is a function from 2, infinity to r. So this 2, infinity over here could be understood as the domain. 2, infinity is going to be understood as what? The domain of the function. So very clearly, x is a value between 2 and infinity. X is a value between 2 and infinity. So what happens to f of x? So f of x is going to be a value between f of 2 and f of infinity. Yes? It's very easy to understand. So try to find out what is f of 2, all of you. What is f of 2? F of 2 is going to be 2 squared minus 4 into 2 plus 5, which is 4 minus 8 plus 5. The answer is 1. And no doubt, f of infinity, no need to waste your time, is infinity. So what is the range? The range of this function is? The range of this function is 1 to infinity. Now students, answer is ready. Answer is 1 to infinity. But this was so easy because they gave me the domain of the function. They gave me the domain of the function, which is 2 to infinity. But it is not that easy always. Sometimes they would not give you the domain. They would say domain is A. Find the range of the function. Domain is A, find the range of the function. Then in that case, I would say this expression is a quadratic equation. This expression is a quadratic equation and you are supposed to use the completing the square method. X squared minus 4x plus 5. Use the completing the square method. It is x minus 2 squared minus 2 squared plus 5, that is equal to x minus 2 squared plus 1. X minus 2 squared plus 1. Now it's very easy. Can everybody please look at the expression over here, which is x minus 2 squared, and there is no doubt that x minus 2 squared is going to be between 0 to infinity. X minus 2 squared is going to be a value between 0 and infinity. So if it is a value between 0 and infinity, what is going to be the value of x minus 2 squared plus 1 is going to be a value between 0 plus 1 and up to infinity. Up to infinity. Okay, so up to infinity means there is no doubt 1 less than or equal to f of x less than infinity. Okay, 1 less than or equal to f of x less than infinity. So what is going to be the range? 1 to infinity. So if they do not give me the domain, please use completing the square method. What method? The completing square method for a quadratic equation. You have learned this method from 10th standard onwards. So you might be knowing it very clearly, completing the square method. Yes? All of you, if you have any doubts, please look at the completing the square method. That would be the best optimum method to find the range of the function. So my answer is 1 to infinity. Both methods are fine. I want you to learn both of it. This is the case when they have given me the domain. Very easy. If they don't give me the domain, you have to find completing the square method and tell the values from 1 to infinity. Okay, let's go to the next question. All of you read the next question. F of x is a function given by x squared plus 1. F of x is a function given by x squared plus 1. And they're asking me to find the pre-image of. They're asking me to find the pre-images of 17 and minus 3. Pre-images of, what is meant by pre-image? That is, if this answer is equal to 17, then what is the value of x? What is the value of x? That is pre-image of 17. We have seen this in the first part itself. Please go back to the first part. You can see what is meant by pre-image. Whenever we are discussing a function, pre-images are always the values of x for which the value of f of x is given. So 17 is given to you. Find the value. So you can say that implies x squared is equal to 16. That implies x is equal to plus or minus 4. X is equal to plus or minus 4. This is going to be the pre-image of 17. Okay. Now let's take the next condition. The pre-image of x squared plus 1 if the value is minus 3. That implies x squared is equal to minus 4, which is not a real number. Which is not a real number, my dear students. Which is not a real number. That is, there is no pre-image. There is no pre-image. There is no pre-image for minus 3. There is no pre-image for minus 3. Okay, there is no pre-image for minus 3. Get it, everybody? Yes, there is no pre-image for minus 3. So what am I going to say now? Therefore, pre-images are plus 4, minus 4, and the other one is having no pre-image, so that is, it is empty. No pre-image. My option is going to be plus 4, minus 4 and empty. Don't take option A because option A says empty first. Empty is not the pre-image of 17. Empty is the pre-image of minus 3. The word respectively is given. Don't be confused. So the first one should be 4 and minus 4. The second one should be empty. Answer is option C. Yes? Okay. Let's go to the next question now. Okay, the function f from R to R is defined by f of x is equal to, the function f of x is equal to 2x plus sin x. The function f of x is equal to 2x plus sin x, and they're asking me about the function being 1, 1, on 2 and all. Okay, let's think about sin x. Here they're saying that x is any real number. X is any real number. So please try to understand the property of sin x. Please try to understand the property of sin x. Sin x is always a many one function. Sin x is always many one, no doubt. Sin x is always many one. What is the reason? Just think, what is the value of sin 0? Sin 0 is 0 and sin pi also is 0. That means I have the same image for two values of x. So it is not 1, 1. Said you would have not learned as many 1. You would have learned it as not 1, 1. Not 1, 1 is also same as many 1. So sin 0 is equal to 0. Sin pi is equal to 0. So it is not 1, 1. This part is not 1, 1. This part is not 1, 1. Okay, but this part over here is 1, 1. This part over here is 1, 1. Why is it 1, 1? You can just use the definition if you want to. That is 2x1 is equal to 2x2 implies x1 is equal to x2. So that part is definitely 1, 1. So when you use a 1, 1 function along with the function which is not 1, 1, the combination of this two, the combination of these two is going to become 1, 1. The combination of these two is going to become 1, 1. So this function is definitely 1, 1. This function is definitely 1, 1. Now what is meant by onto? What is meant by onto? Onto says, what are the values I'm going to get for this? What are the values I'm going to get for this? Let us try to understand. f of x is equal to 2x plus sine x. And they are saying that f is a function from R to R. F is a function from R to R. It simply means that your f of x is also R. Your f of x is also R. That is, I should understand this f of x is all real numbers. So, is there a real number R? Is there a real number R for which there is no pre-image? Sin x says, I am a value between -1 and 1. Sin x is a value between -1 and 1. Sin x is a value between -1 and 1. So sin x says I cannot become any real number, but 2x says I can be any real number from -infinity to +infinity. 2x can be any real number from -infinity to +infinity. 2x can be any real number from -infinity. Okay, let me write this, -infinity to +infinity. So combination is going to be again the same result. The combination is going to be what? The combination is going to be what? The combination is also going to be onto. The combination is going to be onto. So combination of 1, 1 and not 1, 1 is always 1, 1. And the combination of onto and not onto is always onto. Because of the presence of this 2x function, this 2x plus sin x is going to become an onto. Is going to become an onto. So what is my answer? It is 1, 1 and onto. It is 1, 1 and onto. Please mark this question. It could be a very easy and an important question for your boards. Okay, it's a very important question, 2x plus sin x. Okay, let's go to the next question now. Yes, f of x is equal to 3x. Very easy question. F of x is equal to 3x, and they're saying that the function is defined from f from R to R. What is meant by f from R to R? It simply means that my domain is all real numbers, my range is also all real numbers. So the function is f of x is equal to 3x. F of x is equal to 3x. So f of x1 equal to f of x2 implies 3x1 is equal to 3x2 implies x1 equal to x2. So that implies f is 1, 1. F is 1, 1. Is it clear, all of you? Very easy. x1 is equal to the basic definition for proving that a function is 1, 1. I did not use this in the previous question because it is more complicated in that case. That is why I did not try to prove that this is going to be 1, 1 when there is a combination of two functions. No. Just try to understand when a 1, 1 function and a function which is not 1, 1 is put together, the final result is always going to be 1, 1. Okay. Same way, x1 is equal to x2, then f is 1, 1. F is 1, 1. Let's check for onto. Let's check for onto. I would say for onto what? Let y is equal to 3x. That implies x is equal to y by 3. And can I put any real number for y? For any y which is a real number. For any y which is a real number implies x is also a real number. X is also a real number. That is, I have every real number with a pre-image in x. Every real number when I put for y, you get a pre-image in x which is also a real number. So there is no doubt, therefore f is onto. F is onto. Simple definitions, simple functions like this can come in the exam. So you can say f is 1, 1 and onto. F is 1, 1 and onto. Option A, simple definition. Okay, a real number to real number. What if I changed my domain to natural numbers? What if I change my domain to natural numbers? Every natural number is going to give me an answer over there. So it's 1, 1. No doubt it's going to be 1, 1. But what about on to? Y by 3. If I put a real number here, a real number by 3 is not always a natural number. If my domain was a natural number, my answer is that it is not 1, 1. Because every real number in Y does not have a pre-image to become a natural number in X. Got it? So there are elements of Y which are not having pre-images, then it will become not onto. It will become not onto. Okay, let's go for the next question. Yes, this question, I would want to introduce some theory for you. Okay, I want to introduce some theory for you. F of x is equal to x power 4. F of x is equal to x power 4. Here, I want you to understand the theory part here. F is a function from real number to real number. If f is a function from real number to real number, I want everybody to by heart. F of x is equal to x raised to n. F of x is equal to x raised to n is 1, 1, but 1, 1 and onto. Sorry. 1, 1 and onto. 1, 1 and onto. 1, 1 and onto if n is odd. If my n, the power of x, is odd, then f of x is always 1, 1 and onto. Got it? Like x cubed, x power 5, x power 7, even x power 1. All these are functions which are 1, 1 and onto. But if n is odd, second case, if n is even, if n is even, then it is not 1, 1, not 1, 1, not onto. Okay, I will explain the reason for that. Here you have it is even, right? Here you have it is even. I'm going to give you the reason. Reason is, I will take a value. F of 1 is equal to 1 power 4, which is 1. F of minus 1 is equal to minus 1 power 4, which is also 1. So it is very clear, F of 1 is equal to F of minus 1, but 1 is not equal to minus 1. 1 is not equal to minus 1. That is the reason why f is not 1, 1. F is not 1, 1. F is not 1, 1. Okay. Now what about onto? What about onto? I'm considering y is equal to x power 4. That implies x is the fourth root of y. X is the fourth root of y. Now, they're saying y is any real number. Y is any real number. But if y is negative, the fourth root of a negative number, the fourth root, like for example, if y is equal to negative 2, yes, then the fourth root of negative 2 is not a real number. The fourth root of negative 2 is not a real number. The fourth root of negative 2 is not a real number. Therefore, f is not onto. Therefore, f is not onto. F not onto. F not onto. That is why I said it is not 1, 1, it is not onto. It is neither 1, 1 nor onto. Neither 1, 1 nor onto. What else? What are the type of questions which can come from here? Now they could change this over here. My dear students, they could change that. They could say this R is going to be natural numbers. What if they say this R is natural numbers? Real numbers is changed to natural numbers. For natural numbers, definitely you can't take a positive number and a negative number. Only positive numbers. So every positive number is going to make it 1, 1, because it becomes not 1, 1 because of the presence of a negative number whose power of an even number is also same. So if it is natural number to natural number, it is 1, 1. It is 1, 1. Okay. Is it onto? It is not onto. Why? Because the fourth root of a natural number, say 3, the fourth root of a natural number in this n will not give me a natural number x. Got it? The fourth root of a natural number need not be a natural number. So it is not onto. For n to n, you can say that it is not onto when this n is an even power. When this n is an even power. What about odd power? What about odd power? Again, the same reason. It is going to be what? 1, 1. It is going to be 1, 1. But is it onto? Is it onto? Is the cube root of a natural number always a natural number? If f of x is equal to x cube, the pre-image is cube root of x. Cube root of y. Cube root of y. Cube root of y is not always a natural number. So, natural number to natural number is both cases, even or odd power. Even or odd power, both of them are 1, 1, but both of them are not onto. For even powers, real numbers to real numbers, it is neither 1, 1 nor onto. If it is odd power, it is 1, 1 but not onto. It is 1, 1 but not onto. Is it clear? Yes. So let's go for the next question. Yes. Here again a function f of x is equal to 2 power x plus 2 power mod x. F of x is equal to 2 power x plus 2 power mod x. F of x is equal to 2 power x plus 2 power mod x. Is it 1, 1? Is it 1, 1? So let's try to understand. Here the situation is all real numbers to all real numbers. All real numbers to all real numbers. So my x is all real numbers and my f of x is also all real numbers. Let us try to put. Can I put any value for x here? Can I put any value for x here? And is it giving me an unique? It is giving me a unique value for f of x or not? Is it giving me a unique value for f of x or not? Let us try to understand. Let us try to put for any real number. Okay, no need to prove it. No need to prove it. 2 raised to x is an exponential function. Observe it like this. 2 raised to x is an exponential function. 2 raised to x is an exponential function. An exponential function, when you represent this graphically, when you represent an exponential function graphically, it is going to look like this. An exponential function is going to look like this. Can you see that every x has its own y? Can you see? It's very clear. Every x has its own unique y. So it is 1, 1, right? It is 1, 1. So graphically representing f is 1, 1. F is 1, 1. Okay? F is 1, 1. No doubt. What about onto? What about onto? The onto cases, am I getting a pre-image for every real number? Am I getting a pre-image for every real number? Let us look at it. 2 raised to x. 2 raised to x. Can you see? This is y. Yes, y is given to me as, y is given to me. This f of x can be called as y. Okay. Y is given to me as all real numbers. Can you see this graph over here? This graph is staying above the x-axis, right? This graph is staying above the x-axis. So you don't have pre-images. No pre-images for negative real numbers. No pre-images for negative real numbers. If you use the traditional method, it is very difficult to find an answer for this. No pre-images for negative numbers. Negative real numbers. So it is not onto. Therefore, f is not onto. F is not onto. Yes or no, my dear students? Yes, f is not onto. Get it? So what can I say? This function is 1, 1 and it is not onto. F is 1, 1 but not onto. So 1, 1 and not onto, option C. So whenever a question comes in your board exam for asking for 1, 1 and onto for exponential functions are always 1, 1 but not onto. Okay, 1, 1 not onto. But I want you to just look at this case over here. Some of you might think, sir, you're not discussing about modulus of x. Because of the presence of mod x, you just think that 2 raised to x is not there. Just close this part. 2 raised to x is not there. Only 2 raised to mod x. Modulus of x is something which is going to give me the same answer for positive and negative. So because of mod x, this part of the function is not 1, 1. This part is not 1, 1. But in one question we discussed before, I told you a combination of a 1, 1 function. This part is 1, 1. This part is 1, 1. A combination of a 1, 1 function and a not 1, 1 function is always going to be 1, 1. Is always going to be 1, 1. So this is 1, 1. This is not 1, 1. Who cares about not being 1, 1 over there? Because the combination is going to be 1, 1. But if that was alone, it was not 1, 1. It is not on 2 also. Get it? Everybody clear with this? Yes. Hope it's clear. Yes, let's go for the next question. Yes. The type of questions which is very important nowadays. Okay. They're asking you to find the number of 1, 1 mappings onto mappings or 1, 1 and onto mappings. That is injective mappings, number of surjective mappings and number of bijective mappings. So very important. So this question, I'll go by question. Here I want to find the number of injective mappings. The number of injective mappings. Okay. So what is meant by number of injective mappings? It simply tells you number of 1, 1 functions. Number of 1, 1 functions. Number of 1, 1 functions. So, number of 1, 1 functions. What is meant by 1, 1? Every element in the domain has exactly one image in the range. Every element in the domain has exactly one image in the range. Yes, a unique image, preferably saying a unique image which only belongs to that element in the domain. Yes, so it is very clearly said that number of 1, 1 functions of f of x exist only if the number of 1, 1 functions in f of x exist only if you have elements x1, x2, x3 here and elements y1, y2, y3, y4 here. That is, every element in the domain has exact unique image in the range. A unique, that is, it is not sharing with anybody. Okay, x2 will not go to y1, x3 will go to y3, like this. This is a case of 1, 1 function. Every element has a unique image in the range. That is, you have to have an image for every element in the domain and the image over there should be unique for him alone. Unique for him alone. So it is very clear that this is m elements, this is n elements. M elements in the first set, n elements in the second set, then m should be less than or equal to n. M should be less than or equal to n. What if m is greater than n? Then you will not have any injective mappings. If the value of m is greater than n, the number of injective mappings is 0. And if the value of m is less than or even equal to n, then it is npm. All of you remember permutations? Yes? All of you remember permutations from 11th standard? The number of injective mappings is going to be npm. Now look at this question over here. We have set A with 3 elements. Set A has 3 elements and set B has 4 elements. So this is your M, this is your M and this is your N. Yes, so clearly M is less than N. Clearly M is less than N. So I can say my answer is going to be M is equal to 3, N is equal to 4. Therefore, the answer is NPM is equal to 4P3. 4P3. Shortcut method, you have number 3 in the below P. So you have to write 3 numbers from 4. 3 numbers from 4. Very easy shortcut. 4 into 3 into 2. Answer is 24. How many 1, 1 mappings can be made using this set of 3 elements to set of 4 elements? 24 mappings. Option C, 24 mappings. Okay, very easy answer. Learn it, everybody. NPM and NPM formula exists only if m is less than or equal to n. If m is greater than n, number of injective mappings is 0. Okay, next question. Okay, look at the question, all of you. If the set A has 5 elements and set B has 6 elements, then the number of 1, 1 and onto mappings. 1, 1 and onto. That is, they are asking for bijective mappings. What mappings? Bijective. It should be both 1, 1 and onto. It should be both 1, 1 and onto. So 1, 1, we already know that the first set has m elements and the second set has n elements, which says every element in the domain should have a unique image in the range. Yes, unique image. Got it? And onto says that every element in the codomain should have a pre-image. That is, there should not be an element in the second codomain which does not have a pre-image. If there is, then it is not onto, right? So both of them should go 2 and 4th. Okay. So can I say that implies m should be equal to n? What is the condition for an bijective function? What is the condition for a bijective function? The number of elements in the first set should be equal to number of elements in the second set. Okay, let's learn the formula. The formula says that it is going to be m equal to n. This is the only situation where you have a formula. If m is not equal to n, then I would say the number of bijective mappings is 0. The number of bijective mappings is 0. Then what is the formula of m is equal to n? Isn't it going to be npn? npn. Please learn, my dear students, what is npn? It's a formula from 11th standard. npn is n factorial. npn is n factorial. All of you, please learn it. What is the number of bijective mappings formula? Number of bijective mappings is 0 if m is not equal to n, and npn if m is equal to n, which is given as n factorial. What is n factorial here? Okay, now here, what is m? m is equal to 5 and n is equal to 6. Can I say m is not equal to n? m is not equal to n. Yes. m is not equal to n. So the number of bijective mappings is 0. Number of bijective mappings is 0. Option C is the right answer. There are no bijective mappings for such a situation where the number of elements in A is not equal to the number of elements in B. Easy answer? Yes. Go for the next question now. Go for the next question, students. Yes, onto mappings. Number of onto mappings. We learned the number of 1-1 mappings. We learned the number of onto bijective mappings. Now we are going to learn the number of onto mappings, all of you. How to do onto mappings? The formula is a little bit complicated. So I want you to listen very carefully to this. I would always suggest that you learn a situation where the second set has only 2 elements. Usually I've gone through many of the question papers, many of the sample papers. They're all asking you to find the number of onto functions when the second set has only 2 elements. That is so easy. That is, if the first set has m elements and the second set has 2 elements, then number of onto functions or surjective functions, number of onto functions or surjective functions is equal to 2 raised to m minus 2. 2 raised to m minus 2. Please by heart it. I will explain this formula also to you, don't worry. I will explain this formula. 2 raised to m minus 2, which is equal to 2 raised to, in this case, what is m? In this case, what is m? In this case, m is equal to 3. So this is going to be 2 raised to 3 minus 2, which is 8 minus 2, which is 6. So my final answer is ready. My final answer is 6. The number of onto mappings is 6. Get it? The number of onto mappings is 6. But we need to learn but we need to learn a different formula now. The formula is what? Look at the formula, my dear students. The formula is sigma r is equal to 1 to m minus 1 raised to n minus r, NCR and r raised to m, and this works only if m is greater than equal to n. Number of 1, 1, remember m was less than equal to n. Number of onto, m is greater than equal to n. M is greater than equal to n. If m is equal to n, oh, not equal to, I'm sorry, it is not equal to, this is going to be m less than n. If m is less than n, then you are going to say number of onto functions is 0. Number of onto functions is 0. So, m is less than n, number of onto functions is 0. M is greater than equal to n. The formula is sigma r is equal to 1 to m. It's a complicated formula. You can use it and you have to substitute the values of m, n and r. M, n and r. Please, we'll just learn the formula for substitution here. If you see, for example, m is greater than equal to n. So, I'm saying m is some number, I don't know. M is some number which is, and n is equal to 1. What if the second set had only one element? N is equal to 1. So, my answer is going to be summation. We'll forget about summation. So, minus 1 raised to 1 minus 1. The situation is r is equal to 1, right? R is equal to 1. Minus 1 raised to 1 minus 1 into 1 C1 and 1 raised to m. That is equal to, no doubt, the final answer is 1. The final answer, when r is equal to 1 or the number of elements n is equal to 1, n is equal to 1 means you have to only consider the situation when r is equal to 1. N is equal to 2, you have to consider both r is equal to 1 and r is equal to 2. N is equal to 3, you have to consider both r is equal to 3 and n is equal to, r is equal to 1, r is equal to 2, r is equal to 3. So, if I have a set which consists of only one element, the second set which consists of only one element, the number of onto functions is only 1. Number of onto functions is only 1. So, what if n is equal to 2? If n is equal to 2, if n is equal to 2, what happens? I have to take the situation when r is equal to 1 and I have to take the situation when r is equal to 2 and I have to add them up. I have to add them up. What happens if r is equal to 1? Substitute when r is equal to 1, minus 1 raised to 2 minus 1 into 2c1 into 1 raised to m plus minus 1 raised to 2 minus 2, okay, into 2c2 into 2 raised to m. Okay, so this is going to be minus 1 raised to 1, which is minus 1, okay, into 2c1, which is 2, plus minus 1 raised to 0, which is 1, into 2c2, which is 1, and 2 raised to m. So my answer is equal to minus 2 plus 2 raised to m. That is why I told you to by heart this formula, minus 2 plus 2 raised to m. Difficult to derive it. So when they ask you a question with the second set having 2 elements, directly learn this formula. Directly learn this formula, 2 raised to m minus 2. That is enough. That is enough for you people. Okay. But I will be doing a question with three elements. I will be doing a question with 3 elements. Okay. Okay. The next question consists of number of onto functions. Number of onto functions. Okay. N of A is equal to 6. N of B is equal to 3. N of B is equal to 3. Got it? So I have my number of elements in the first set is equal to 6 and the number of elements in the second set is equal to 3. So I have m greater than n. According to the definition, m should be greater than equal to n, right? M should be greater than equal to n. M should be greater than equal to n. So I have m which is greater than or equal to n. I have an m which is greater than or equal to n. Okay. So let's try to do this question now. Okay. So what is the formula again? I have to do for r is equal to 1. I have to do for r is equal to 2 and I have to do for r is equal to 3. Yes, substitute and see. What is the formula once again? The formula says minus 1, yes, minus 1 raised to what? Minus 1 raised to r minus n minus 1. So 3 minus 1. Minus 1 raised to 3 minus 1 into 3c1 into 1 raised to m. 1 raised to m. Next one, minus 1 raised to 3 minus 2 into 3c2 into 2 raised to m. Next one, minus 1 raised to 3 minus 3 into 3c3 into 3 raised to m. Yes? Everybody clear with this? Yes? Okay. Now what is the answer for the first one? Please calculate. The answer for the first one. Minus 1 squared is 1. 3c1 is 3. So this answer is 3. Second one, minus 1 raised to 1. It's minus 1. Minus 1 into 3c2. It's 3. So it's minus 3 into 2 raised to m. Minus 3 into 2 raised to m. This answer, minus 1 raised to 0 is 1. Minus 1 raised to 0 is 1. 3c3 is 1 and with 3 raised to m. So that is 3 raised to m. So the sum is going to be, therefore, number of onto functions. Number of onto functions. Number of onto functions is equal to 3 minus 3 into 2 raised to m plus 3 raised to m. And my m is 6. M is 6, all of you. Learn it. M is the number of elements in the first set. That is given to be 6. So substituted, that is equal to 3 minus 3 into 2 raised to 6 plus 3 raised to 6. It is not going to be any of the answers that is given to in the options. None of the answers, okay? Or maybe it is 340, but 3 raised to 6. Let us see what is 3 raised to 6. Is it a very big number? Yes, 3 raised to 6 is a very big number. 3 raised to 4 is 81, 243, 729. 729 minus 64 into 3. No, it's not going to be anything. It's not going to be 340. So my answer is going to be none of these. Option D, none of these. So number of onto functions is going to be none of these. Next, A and B are having elements 4 and 6 respectively. Then the number of 1 functions. Number of 1 functions. So m is equal to 4, m is equal to 4, n is equal to 6. The number of 1 functions is always considered when m is less than or equal to n. M should be less than equal to n. Definitely, correct? Yes. Therefore, what is the number of 1 functions? Number of 1 functions. 1 functions. Number of 1 functions is equal to npm. That is equal to 6p4. What was the technique I told you? The number below is 4. So you write 6, 5, 4 and 3. That is, you have to multiply 4 numbers from 6. 6p4, 4 numbers from 6. Multiply, 6 5s are 30, 30 and 3 and 4 is 120, 120 and 3 is 360. So your answer is 360. Option C, 360. Very easy answer. Yes. Look at it very carefully. If it comes, short answer, npm. npm is the formula for 1 functions. When it becomes 1 and onto npn, which is n factorial. Both of them should be equal. For 1, the first set should have lesser number of elements. For onto, the first set should have more number of elements. Okay. Okay, next question. A and B have 4 elements each. A and B have 4 elements each. Okay, so number of elements in A, m is equal to 4, and the number of elements in B, n also is equal to 4. The number of 1 and onto bijective functions. 1 and onto condition is m should be equal to n, right? Here m is equal to n. Therefore, number of bijective functions. Number of bijective functions, all of you. What is the number of bijective functions in this case? Number of bijective functions is equal to npn, which is equal to n factorial, which is 4 factorial. 4 factorial is 24. 4 factorial is 24. Option B is the answer. Option B is the answer. Yes, very easy approach again. These kind of questions I'm repeatedly doing because there is a chance expected question this year around. Okay, though it's not there in the NCERT textbook. These kind of questions very important for your CBSE board exam. Okay, next one. Okay, this is the domain of the function. It's 11th standard concept. It is there in the sample paper, so I had to take it out. So domain of the function for the square root of x squared minus 4. F of x is equal to the square root of x squared minus 4. So from 11th standard we have learned that whatever is inside the square root, x squared minus 4 should be greater than or equal to 0. X squared minus 4 should be greater than or equal to 0. That implies x squared should be greater than or equal to 4. X squared should be greater than or equal to 4 means that x should be greater than or equal to 2, or x should be less than or equal to minus 2. Because if I take a number which is greater than or equal to 2 for x, it is the square of that number is going to be greater than or equal to 4. Say 3. 3 squared is 9, greater than 4. Say a number which is less than minus 2, minus 3. Minus 3 squared is also 9, which is greater than 4. So the negative numbers less than minus 2 and the positive numbers greater than 2 are going to give me always a squared which is greater than or equal to 4. So what is my domain? What is my domain? Therefore, x is any real number. X is any real number which is less than minus 2. So minus 2 up to infinity. Minus 2 up to infinity. Minus 2, I'm sorry. Minus 2 up to negative infinity. Minus 2 up to negative infinity. Union greater than 2, positive 2 to positive infinity. Positive 2 to positive infinity. So look at the options. Minus infinity to minus 2 union positive 2 to positive infinity. Okay. Positive 2 to positive infinity. So the option is going to be option C. Okay. The option is option C. So I believe everybody is clear with this answer. Yes. Let's go for the next question. Okay. F is a function from R to R which is defined by f of x is equal to 3x for x greater than 3, x squared for any number between 1 to 3 and x for any number greater than or equal to 3. So I think the first option there is a mistake. So this is going to be like x less than 1, x less than 1, x less than 1. Okay, got it? And this is x greater than or equal to 3. Okay, fine. Now what is f of minus 2 going to be? F of minus 2. F of minus 2 is a value which is less than 1. So it's going to be 3 into minus 2. That is equal to minus 6. So this function, I'm using this function. Okay. Next, f of 0. F of 0 is equal to a value which is less than 1. So 3 into 0. That is again 0. Then f of 2. F of 2. F of 2 is a number between 1 and 3. So it's going to become 2 squared which is equal to 4. 2 squared which is equal to 4. Last one, f of 5. F of 5 is a number which is greater than 3. So it's going to be x which is 5. Therefore, what is the sum? Minus 6 plus 0 plus 4 plus 5. And the answer is 4 plus 5 is 9 minus 6 is 3. None of these. None of these. Okay. It's very clear answer. None of these. Not 0, not 70, not minus 4. It's none of these. Okay. Yes, the domain of a log function. A very particular question for 12th standard. The domain of a log function. For that, I want you to understand that log x means that the base of the log is e. The base of the log is the exponential form e. Okay, so what if I have a property in log which says that if some other base is used, then I can rewrite this as log x divided by log b. So it is assumed that now the base is e. I'm just converting the base to e as a log property. So now I will understand this question. The question says log of x squared minus 1 with the base of 3 plus x. The base is 3 plus x. The base is not e. The base is 3 plus x. So this can be rewritten using this property as log of x squared minus 1 divided by log of 3 plus x. Okay, they're asking me the domain of this. Domain means the value of x. Domain means what? The value of x. They want me to find out the values of x for which this function is defined. For that, we need to understand what is the domain of a log function. Whenever you have a log of x, this implies that the value of x should be greater than 0. The value of x should be greater than 0. Now look at this over here. You can see that this x squared minus 1, x squared minus 1 is inside the log, so it should be greater than 0. That implies x squared should be greater than 1, implies x should be greater than 1 or x should be less than minus 1. X should be greater than 1 because x squared, the same case of what we discussed before. If x squared has to be greater than 4, then x should be greater than 2 and x should be less than minus 2. Same way, x should be greater than 1 or x should be less than minus 1 because it is in the numerator. Okay. But in the denominator, let's see. The denominator says that it is 3 plus x. So 3 plus x also should be greater than 0. 3 plus x is also greater than 0. Okay, 3 plus x is also greater than 0. That implies x is greater than minus 3. X is greater than minus 3. But there is a very important condition here. Remember, but log of 1. 1 is a number which is greater than 0. Log of 1 is equal to 0. What is the log of 1? Log of 1 is 0. If log of 1 is 0, the denominator is there a chance that this can become 0. This can become 0, then that implies it is a log of 1. That is 3 plus x is equal to 1. Then this becomes 0, right? So can I say that x equal to minus 3, then this is going to become x equal to minus 3 is going to make it, x equal to minus 3 is going to make a problem for this. X equal to minus 3 cannot come. But look at the condition here. 3 plus x should be greater than 0. No, sorry. X equal to minus 2. My mistake. X equal to minus 2. Three plus x means x equal to minus 2. So x cannot become minus 2. X cannot become minus 2. So when you say x greater than minus 3, you have to link it with this and say that x cannot become minus 2. Look at the option, x should be greater than 1. So for understanding this, let us look at the number line now. All of you, look at the number line. All of you, please look at the number line. They are saying that x should be greater than 1. X should be greater than 1. Okay. Then x should be less than minus 1. X should be less than minus 1. Okay. Then x should be greater than minus 3. X should be greater than minus 3. So all values greater than minus 3. X should be greater than minus 3 and x should not be minus 2. So it should not be minus 2. It should not be minus 2. So I want the domain where the values of x is from minus 3 to minus 1 without minus 2 and the values of x greater than 1. So minus 3 to minus 1 without minus 2. Look at the option. Minus 3 to minus 1. Look at this option. Minus 3 to minus 1, an open bracket for minus 2. This is minus 2 is excluded. And then from 1 to infinity over here. So this my answer is option C. My answer is option C. Little bit twisted question because you are having a log form in the denominator as well. Even if those students who understood what is log, this part would be confusing. Why not minus 2? Because if I put x is equal to minus 2 here, I will get 3 minus 2, which makes it 1, and log of 1 is 0. Denominator 0 means it's not defined. So I have to exclude minus 2 also. Please look at this question. It's a very, very important question. The log question. I'm not saying this exact question is going to come. The log form domain could be a question in the question ranges from 41 to 45. A little bit higher level questions come in that category of the question paper. Okay, next question. F is a function from R to 0 to pi by 2 defined by f of x is equal to tan inverse of x squared plus x plus 2a. Okay, tan inverse. Then what is the values of f? A, for which f is onto. F is onto. What is the meaning of onto? Onto means every element in the codomain. Every element in the codomain should have a pre-image. Every element in the codomain should have a pre-image. Now, it's a very easy understanding. Tan inverse has its own range. Tan inverse says that my range is between minus pi by 2 and pi by 2. My range is between minus pi by 2 and pi by 2. But they are saying, I don't want from minus pi by 2 to pi by 2. Here I am only concerned about the values from 0 to pi by 2. I'm only concerned about values from 0 to pi by 2. That implies, can I say tan inverse x is greater than or equal to 0? Forget about pi by 2. Greater than equal to 0. It has to be greater than or equal to 0. That implies whatever is inside x should be greater than or equal to tan 0. What is tan 0? Tan 0 is also 0. So I can say whatever is inside the capital X should be greater than or equal to 0. Capital X is greater than or equal to 0 implies x squared plus x plus 2a is greater than or equal to 0. I told you quadratic equation. Here I don't know what is my domain. Remember completing the square method which we discussed a few questions back. Completing the square method which we discussed a few questions back, which tells me that whenever you have a quadratic form, use the completing the square method. What does the completing the square method tell me? That implies x plus 1 by 2 squared minus 1 by 2 squared plus 2a is greater than or equal to 0. I want this to be greater than or equal to 0. Now look at this part by part. I want everybody to look at the first part. It's a squared form, so there is no doubt this is greater than or equal to 0. And the next part should also be greater than or equal to 0, right? If the second part also is greater than or equal to 0, then only my final answer is going to be greater than or equal to 0. This is very clearly greater than or equal to 0. This also should be greater than or equal to 0, so that my answer is going to be a positive number. So can I say that implies minus 1 by 4 plus 2a is greater than or equal to 0. That implies 2a is greater than or equal to 1 by 4. That implies a is greater than or equal to 1 by 8. A is greater than or equal to 1 by 8. A is greater than or equal to 1 by 8. Okay. So what is meant by that? That means the value of A should be more than or equal to 8. More than or equal to 8. My answer is option D, greater than or equal to 1 by 8. 1 by 8 to infinity. Please mark this kind of question. Inverse trigonometry question. Inverse trigonometry question coming for 1112. A very prominent question for a higher level question paper. Okay. So f of x is equal to tan inverse of x squared plus x plus 2a. We understand that tan inverse x is from minus pi by 2 to pi by 2. It's a very important topic in inverse trigonometry, where you have to learn the domain and the principal value branch of inverse trigonometry function. This is a principal value branch of tan inverse from minus pi by 2 to pi by 2. But here they reduced it from 0 to pi by 2. So I understood that tan inverse x should be greater than or equal to 0. Okay. So very clearly answer is done. Now let's go for the next question. Next question, they are giving me f and they're giving me g. And they're asking me about f minus g. All of you, look at the question. F is given by 0 if x is a rational number and x if x is an irrational number. What about g? G says, okay, G says g is equal to x if x is a rational number and 0 if x is an irrational number. From this, please combine. What is f minus g? F minus g, combine the rational forms. 0 minus x, which is equal to minus x if x is a rational number, and x minus 0, which is equal to x if x is an irrational number. So I found out what is f and what is g, and f minus g is given. So f minus g is minus x and x. We have to check if it is 1, 1 and onto. Just simple observation is enough. Is it 1, 1? If I put a rational number here, every rational number is positive. For every positive rational number, this answer is going to be negative. Yes, for every negative rational number, the answer is going to be positive. Yes, got it? Very simple. Positive rational numbers becomes negative, negative rational numbers becomes positive. So it is definitely 1, 1. No two elements is going to have the same image. No two elements is going to have, one is going to give me positive, the other is going to give me negative. Okay, what about irrational numbers? Positive irrational numbers become positive, negative irrational becomes negative. Yes, so can I say that my function is 1, 1, f minus g is 1, 1? F minus g is 1, 1. Simple explanation why? Every positive rational number gives me negative of that number, and every negative rational number gives me positive of the number. So I am getting all the positive rational numbers, all the negative rational numbers, including 0. What about irrational numbers? I am getting all the positive irrational numbers, I am getting all the negative irrational numbers. Yes, so it is 1, 1. For every x, there is a unique y. Got it? So it is 1. What about onto? Onto says every element in the codomain, every element, look at it, it is R, set of all real numbers, set of all real numbers to real numbers, right? So my codomain is going to be what? My codomain is R. Codomain is R. Yes, so codomain is R. You have learned in 11th standard that real numbers is the union of rational and irrational numbers. The union of rational numbers and irrational numbers together is real numbers. So every rational number is obtained in f minus g. Every irrational number, positive and negative, is obtained in f minus g. So I can say that therefore f minus g is onto also. F minus g is onto also. Look at the options. 1, 1 and onto, option A. 1, 1 and onto, option A. It's very simple understanding. Write what is f minus g, and it's very clearly 1, 1. It's very clearly onto. Yes. Next question. Next question. F of x is equal to tan inverse of 2x by 1 minus x squared. F of x is equal to tan inverse of 2x by 1 minus x squared. Again, they're asking me what is b? What is b? It's a very direct question, my dear students. Very direct, because we know that tan inverse x is having its domain. Domain has all real numbers, but range is minus pi by 2 to pi by 2. Yes, so what is going to be the range of tan inverse of 2x by 1 minus x squared? That is going to be also between minus pi by 2 and pi by 2. That is also going to be a value between minus pi by 2 and pi by 2. So what is going to be b? Therefore, b is equal to minus pi by 2. The range minus pi by 2 to pi by 2. No need to waste your time to simplify all these things. Minus pi by 2 to pi by 2. Yes, so I believe that I've covered almost all possible questions from this chapter. Okay, so I will be coming back with the next chapter very soon. inverse trigonometric functions, chapter 2. Discussion will be coming very soon. So everybody, please go through the questions one by one again, and I expect that you would be getting almost all the questions from this discussion, which covers almost all the concepts of the first chapter. So it was very nice class, I guess. So everybody, thank you and have a very good day.